Hey y'all, we're starting Unit 3, home stretch. This is super short, I promise. It's like 3 or maybe 4 big. So first of all, we're talking about isometries. All of Unit 3 is transformations. It's all taking a shape and moving it around. Isometries keep the two shapes the same. They're congruent. So there's 3 types of isometries, and I'm going to try super hard to keep these on the same page, but I might take 2 pages. So just so you're mentally prepared for this, I have a lot to cover, and this doesn't even have any examples on it. So let's get started. So the first type of isometry is a translation, which is when a shape slides around. Slide to the left, slide to the right. Is that even left and right for you? I don't know. It's left and right for me. So here's what a translation looks like. I started writing it down here, but don't worry about that. Okay, so it looks like this. It goes XY, which is the original shape. It's called the pre-image. It's the OG triangle usually. And then it goes to the image. And what we're doing is we're going left or right by A. So if it's a plus A, it goes to the right. If it's a minus A, it goes to the left. And up or down by B. Now this specifically is called vector format. There's a bunch of different ways that different groups of people can show translations, but this is the most common one I found. So we're going to keep it like this. Before I used to do a big T with how it changes, but this is the most frequent, especially on tests and stuff. And it's what your book uses. So XY, so X plus A, Y plus B. So if I did like X minus 3, Y plus 4, what I would do is I would take whatever the shape is and I would move it left 3 and up 4. And I know that X is this axis, so it is left and right, and Y is this axis, so it is up and down. So that's just how that kind of works. Hey, I'm doing pretty good. That was like a third of my page before. That's going to be pretty easy to keep going. But actually, I should show you an example, huh? Yeah, I should show you an example. Okay, so here's, it's going to take 2 pages if I show you examples. But I think that's more useful, so a lot of you like examples anyway, so we're just going to do it. We're just going to roll with it. If you want to keep this on 1 page and you don't want to show all the examples, I don't care. Because I want to show you how this kind of looks. Okay, so I'm going to keep this same one. So if I wanted to go left and up, I kind of want to keep it down here. So maybe I'll have this triangle kind of look like this. Let's name this ABC because of reasons. So if you want the actual points, A is at 2, 0, B is at 3, negative 3, and C is at 0, negative 2. And I'm going to move this whole thing X minus 3 and Y plus 4. So I'm going to go back 3, 1, 2, 3, and up 4. 1, 2, 3, 4. Dang it. And then back 3, 1, 2, 3, up 4. 1, 2, 3, 4. And then same thing. Actually, let me show you a trick. B is over 1 and down 3 from A, so I can actually do that over here. So I don't actually need to do the whole thing, but it would be the same as if I got 1, 2, 3, 1, 2, 3, 4. Okay, now this was the pre-image. This is the image. What we say is this is the new A, the new B, and the new C. So triangle ABC is the pre-image, and then triangle A prime, B prime, C prime is the image. And this is, so this little thing says prime, and it means the new. If you did it 3 or 4 times, which we're going to talk about in 3C, you would do more than one little for every time you move it. It's like a little feet symbol up here, though, if that helps you. So the new ABC is there. In the book or on examples, I might do them as different colors and say, how does the black one map to the red one? The black one here, let's say, would be the pre-image, and then it maps to the red one. Mapping is how you say the word like slide around or whatever. Okay, so let's try reflections next. Okay, so here's the next one's reflection. It means flip. It's just, actually, let me show you. I can't, hold on. Okay, it's like this. Ready? Whoop. You're used to this because this is just how class is normally. I can't put myself back. Uh-oh, hold on. I fixed it. We're good. That scared me for a second. It didn't go back right away. Okay, so reflection is just flipping it over something. Now, instead of saying over, what they say is in the x-axis or in the y-axis, which is super dumb, I know, but it's just how people do it, and we have to go along with it, I guess. So it'll look kind of like this. It'll say reflect the shape over in the whatever axis. So this could be the x-axis. This could be the y-axis. This could be the line y equals x. This could be a line like y equals 1 or x equals -3. And so all of those, I think you know how to flip things, but I want to identify all these axes for you. And I might as well just do an example while I'm at it because I want to make sure that you are feeling successful. So let's do this. All right. So this right here is the x-axis. I know that you learned this before, but I also know it's been at least 4 months since we've even talked about algebra. Well, no, we did in proofs, but we didn't talk about graphing. This diagonal line is the line y equals x. And then if you wanted y equals 1, it would be up 1, it would be flat. Now I get to do all this for all of these. And if you wanted the line x equals -3, it'd be through -3 and it'd be up and down. Okay, so those are all of the lines. It's also going to start asking you about like what quadrant does this end up in. But we're going to talk about that more next time, so I won't write it on here. Or not next time, but at the last one. Yeah, I'm going to show you an example down here. So we are going to use a page and a half, and I apologize dearly. I have to do it too. Get over it. I'm a jerk. I love you. I don't need no man. Okay, so we're going to say, let's say reflect triangle. Let's not do ABC. Let's do cat. In the, what do we want to call this? What line? Let's do y equals x because it's hard. So I'm going to take this graph and I'm just going to make up the same, I'm going to make up a triangle. So let's just call it, let's do it down here again. What is that? 2. Hey, let's just do the same one as before because I don't have any creativity right now, and that's okay. By golly. Cat. So this is triangle cat. You can draw a cat if you'd like. And then this is the line that we're going to flip it over. So let me just get a color really quick. Like this one. It's going to be this line that goes straight up and it goes up 1 over 1. And I should just label the whole graph right here. So let's go boop, 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 boop. Beautiful. Okay, so how this works is that we're going to take every point and we're going to move it the same distance over this line as it was before. So this one is, it's going to be right here. How do I say this a different way though? So it's basically like a couple up, and so we go over, right? It's like 2 up, and so we go 2 over here. So that's new A. This is a hard one. That's why I don't usually do it. This one, it's like, I wish there was actual lines on here. Hold on, I can do that for you. The blue lines are confusing to look at, but look. Okay, so this is a whole half, like it's a diagonal square away from the line, and so we can go a diagonal square more. That's really what's happening here. It makes more sense when you see it. This is a whole diagonal square away, so we go a whole diagonal square away more. That's new C. And then T, let's see, T is 1, 2, 3 diagonal squares away, so we go 1, 2, 3 diagonal squares more. That's T prime, or new T. Yeah, it sounds like Optimus Prime. So I just took the original cat and I flipped it over that line and I got the new cat. This is the image. This is the pre-image. It's the image before I did anything to it. It's why it's called the pre-image. So over here, questions might include like, where would the new A end up? Or like, where's the whatever? And so you'd have to just know how to find points. Like this is 0, 2, this is -2, 0, this is -3, 3. We'll get there. Okay, one more page, but we'll probably only do half because I just need to do rotations. Okay, this is 3 continue. We're doing rotations. Now, rotations are like a turn. And what these ones say is it says about blank. This is generally the origin, but it could be any point technically. I think that we're going to keep it low level with just the origin, but I might do some challenge problems where I give you points like the 0.11 or something like that. So let's talk about how to do this. Actually, no, first I'm going to define 2 terms for you. Clockwise and counterclockwise. Now a clock goes, oh no, it's heckin' upside down. A clock goes like this, right? Goes like this. So clockwise follows the clock. So in this case, it goes down to the right to me, right? It follows a clock. So it goes like this, which means it goes to the right. And counterclockwise goes the other way of a clock. It goes the opposite way, which is this way around, which is basically to the left. Why don't we say right and left? I don't know. I don't know any of these answers. Maybe one day I'll know, but usually we talk about clocks instead of right and left. Maybe it's because people see clocks and don't know what their right and their left is. That would be embarrassing, wouldn't it? Okay, so if I take any shape, I'm so glad I actually have the space for this. I'm glad I did it with 1.5 pages, and I'm so sorry if you're mad at me for it. Okay, so whatever the shape is, let's say I have a shape up here in the first quadrant. Okay. If I take this shape, and we always talk about rotating counterclockwise. This is the main one. So if I went 90 degrees counterclockwise, what I would do is I would take every point, that's usually like an XY point, right? And I would make it -y, x. And basically what would happen is I would be rotating my paper with this point as the center. And so this point would end up here. This point would end up, I have to do this in my head actually. Not that high though. Well, that high, but not that close. Let me do that. That's white out, by the way. Did you know that? I actually might end up in my other triangle here, but it'll kind of look like this. It doesn't look like that. It'll be rotated though. We're going to do some examples that are real life and I'll show you. But if I did it as 180 degrees, what I would do is I would take and just switch the two things. Or no, sorry, make them both negative. So it'd be -x, -y. And so I don't want to estimate the picture down here. Don't judge me. And if I went 270 degrees counterclockwise, I would call it y -x. Yes, I'm peeking at my notes over here because I like to think about it logically and not using these XY things, but I do want to show you this because it actually makes it a little bit easier. So let's say that I had triangle. I'm running out of ideas here. Geometry, GEO. And I say like G is at 1, 1, and then E is at 2, 3, and that O is at 3, 2. I don't know. So if I were to rotate this, let's just say 90 degrees counterclockwise. Hold on. Listen, I ran out of room, but you know what I mean. Counterclockwise. Then I would switch the X and the Y, and I would make the Y negative. So it would be -1, 1, -3, 2, and -2, 3. So that would be my new G, E, and O for geometry. So I switched X and Y, and I made the Y negative. It's the same kind of thing around a point. You would just basically like move the point to be what you want and then switch it and then put it back. That doesn't really make sense, but you got it. You know. All right, and then one last thing is I want to just remind you of the origin is 0, 0. There's some terms here I want you just to remember. And then here are the quadrants. The quadrants just count from 1 to 4 and they make a C shape. So if I were to draw a C on here, here's 1, 2, 3, and then 4. Like it's exactly how I draw a C. 1, 2, 3, 4. And yes, they're Roman numerals, and yes, you're supposed to write them that way. Sorry, not sorry. Okay, I've been talking too long. That was a 15-minute video. I'm so sorry. I'm supposed to keep these down to like 5, and I just keep failing. But I hope that helped. I'm hoping it all helped. We're going to do so much practice on this, but this is the beginning of transformations. Welcome.